Speakers, Nicholas and Lenz, who will introduce each other anyway.
Thank you. Thank you. Good morning. Good morning. I'm Nicholas, the guy with the Hungarian surname, but I was born in Uruguay. And actually, I'm a New Zealander, so I'm married, a clinical psychologist, and she helped me with identity crisis. And here is Lenz, who is German, born in Austria, also living in New Zealand. So we are who we are, I'm sorry. But what it matters is, I guess, what we do. And Open Parallel, it's an ecosystem, a company that we are organizing. And we do specialist projects, essentially, for communities or big corporations, to be honest, to whoever pays us. And what we want to present you is this specific project that we did along the whole good part of 2010 and 2011. And before that, we will introduce you why this is around the multi-core and parallel programming. So we will give you, hello? Yes. So this is what the presentation is about. I will give a general introduction about what is this multi-core hardware chips and why parallel programming is the solution. I will explain about the Open Parallel ecosystem and obviously invite you to join us. And then Lenz will take the hardcore part, and hopefully we will be able even to show you something live or not. And we will end explain you how our long-term strategy is progressing, something that we started a few years ago. So here are business cards, a small leaflet, and please feel free to interrupt anytime. We are not shy, we are not humble. So. And by the way, thank you very much, all of you, for being here. I know that we are competing against other presentations, so off we go. Well, sorry, I was expecting here to change. Right, so let's tell you a story. If Bruce's parents just read the slides, I can read a few slides too. But this is a nice story, and I strongly encourage you just to read it together. So we have a software crisis. We have a problem, and we wouldn't have that problem if we didn't have machines to program. I mean, 30 years ago, I was lecturing mathematics, and believe me, a piece of chalk and the blackboard, that was, if not romantic, it was at least historic. Computers made a problem. Oops. And we have this issue that vendors and manufacturers are creating hardware that we just need to learn how to program. And the interesting thing is that the power that these machines have, it's something that we need to handle that. Let me highlight. I learned Fortran 30 years ago, but I'm an entrepreneur. So I forgot Fortran 29 years ago. I remember Go too, which is helpful to go to the bathroom or whatever. But what are we building here is an ecosystem of, in the area of multi-core and parallel computing. So this was part of a Turing lecture from a gentleman with Dutch surname, Edgar Dijkstra. The interesting thing that he said this in 1972. And why I am quoting this story, because it's pretty much the same what's happening to us today. We have extremely powerful hardware, and we are just behind on how to take advantage of that. So there is software crisis after crisis. And what is this multi-core hardware? Well, this lovely laptop that I have here has 2 or 4 cores. But why we have this core situation? Because after Moore's law was giving crappy code developers always a solution year after year, by saying, whatever your performance is, I will give you a way to speed up next year. This doesn't work anymore for the last 5 or 6 years. And why? Because nature, heat, dissipation. So if you want to read more about this, there is an interesting short paper, absolutely in a general way. But the challenge is how to take advantage of these chips. Why are we concerned about? Because we can start to do things that we never thought that we are able to do before. Again, this has 4 cores, perhaps. 705,024 cores has a supercomputer, which is the fastest and best performance. There is a list of top 500 about supercomputers. Then you can ask me, why are you talking about supercomputers? Why high-performance computing this is not scientific computing? Well, the story is that hardware, it's coming to our budgets. Today, you can buy, actually, a supercomputer. And the software to run it, either from Red Hat, will cost you pretty much the same. So you actually can have an extremely powerful hardware for a cost that was absolutely unheard before. So what we are thinking is not only to do things faster, but things that you haven't thought before. And there are incredible projects, and there is one that involves Australia and New Zealand, for example, the Square Kilometre Array, the SKA, which will, I don't know, track data back to the Big Bang. And the amount of data that needs to be processed daily, someone say that it's equivalent to what the internet is processing on its entire 40 years of history. So we're talking about big things, which means that we're talking about the Internet of Things, the big data, all these trendy names that are around, but someone needs to process that information, and software needs to be written, and we have the hardware. So it's time to take some decisions. And those decisions could go through one way or other. Sequential programming is dead. Sequential programming is dead. And if it's not dead today, it will be tomorrow or yesterday. We need to go to learn certain ways to parallelize to take advantage of existing hardware. So you need to take some decision about how to reach that. And you need to be aware that parallelism is already with us. It's already with us everywhere. And we would love to believe that it's nice and shiny with a beautiful blue sky, everyone going in parallel, everyone coming, love and peace. But it's not like that. So, and even if you don't see that, you see that jamming up there. So it's not that simple. It's not that today I was in one world and then I shifted to other world. It's not that I have a holy grail that says, this is my software that parallelizes automatically everything. It's just not that simple. So sometimes it's better to ask someone else to speak on my behalf. So this couple of gentlemen has another paper. And what they say is that parallelism is not new. But the realization that it's essential for HPC high-performance computing is. Again, high-performance computing is not anymore on the realm of science. You don't need necessarily to have a PhD in computer science to deal with it. The hardware, it's readily available. But the question is how we will deal with this. And there is a lot of research and a lot of information available. And a lot of people have been trying to find the right language. So these are languages for parallel programming. And someone said that there are actually 200 of them. So what I put in bold, this is after half morning of research, what I put in bold are the names that I heard about it, people on our team know how to do, but there is just a wealth of options, which doesn't mean that we have a wealth of solutions. So as an entrepreneur, it's my dream There is a big gap in the market. There is a big problem that we can address it. So forget technology, forget software, simple business. There is a need. I will try to provide a solution. Simple like that. And the problem is precisely here. These four horses are here. In one way or other, the legacy code is taking advantage of the course here, but sometimes even goes slower. The challenge is to use these new chips, which, believe me, are cheaper, faster, perform better, but you need to know how to program them. So in terms of change, you need to make decisions. And probably in a team or in a boardroom, you are the only one who has an idea, because everyone else believes that the status quo is how it is and should stay like that forever. And, okay, this is my daughter. She will hate me because I am showing this photo. But the point is, we need to find a way to create solutions to this problem. Open Parallel, it's a company, but essentially it's an ecosystem which integrates entrepreneurs, engineers, developers, academia, investors. I want to call it our own virtual incubator, our own virtual Silicon Valley. We won't lecture about, yes, there is a distributed world. Well, actually, we believe that the only way to address this software problem is through the business model, if we can call it, of the open source community, integrated with a lot of other solutions. So this is a direct invitation to everyone in the room or who is watching to join us. And from here, we will explain a specific project about how we did this. Lens.
So, is that on? All good? Sweet. Good.
You want this?
Let's talk about the actual technical stuff now.
Thank you.
We've done a project with TBB because we think TBB is a really, really good library to actually address a lot of parallel programming issues. It's been written by Intel, but it is open sourced, and it is actually open sourced in a way that you can even relabel it and resell it. I think Microsoft resells their threading library as a direct copy of the actual Intel project. So it is relabelable, or however you call that. But it is actually a really, really interesting project, because Intel obviously wants to sell chips with many cores, and they thought, how can we probably make that a bit easier and approachable, more approachable for average developers, without trying to make them know everything about how hard it is to synchronize threads and all that kind of stuff. So they came up with TBB, and TBB is a C++ library that gives you a task-based interface towards addressing multi-core problems. So you can basically track up your project in multiple tasks and make those tasks communicate via queues. And they give you all the mechanics for it, so that it is really pretty simple to actually do that without having to worry about synchronization, without having to worry about shared memory and all those kind of things. So we love this approach, but it is C++. C++ is not exactly the language that is used on the web, and the web is, from my perspective, the more important bit of the internet, because we know how to program servers, but that's something that a minority does. The majority on the web development is done in app servers and on websites and stuff. So we try to bring TBB to a wider audience. And sorry. And we tried to get it into PHP. The problem with PHP is it doesn't thread at all, at least not send PHP. We actually started to to implement or to try to hack the send PHP runtime to thread properly, but people tried it before us, and also we failed. So it hasn't been done yet, and there have not been many encouraging words from the core developers that it will ever work. So we set out to actually hack hip-hop, which is a project that a small startup has written called Facebook. They had the same problem. PHP works nicely. The problem is only performance is suboptimal if the site gets bigger. So they came up with hip-hop, which is a PHP to C++ compiler, which fits pretty much exactly our needs, because C++ is also the thing TBB is written in, so we thought we can probably really easily just sort of sneak into the language interpreter of hip-hop and implement a couple new commands like parallel for, parallel reduce and stuff to just modify the commands or the namespace of PHP and give PHP the ability to do, for example, a parallel for over an array on multiple CPUs. Turned out it wasn't that straightforward, but we managed to do it. Hacked it in, added TBB to hip-hop, and actually added a subset of the TBB library as an initial step to just try to evaluate if it works at all. We have currently in there parallel for and a parallel reduce, and we have all the data structures that we need to deal with them in a way that TBB can actually make sure that we are using multiple cores and the shared memory is used efficiently and all that. So why? Well, hip-hop is already something that is used by not only by Facebook but by a couple of other large players, and it doesn't address the sort of, I don't want to say normal, but the guy who implements 3 lines of PHP in his static HTML website to implement a counter or update the date. It is already addressing a very tech-savvy audience already. So we thought it's probably the right audience to actually address the multi-core problem as well, because they're already performance conscious. They're already sort of open for the problem, and we wanted to give them an opportunity to execute tasks in parallel, to actually go through the code base, look for parallel for side effect free for loops and run them in parallel, and do that efficient thanks to TBB and hip-hop, and do that in a stable way thanks to TBB, because TBB already takes care of all the memory management and locking and things. So effectively, we have threaded PHP if we run under hip-hop, and it surprisingly works. pretty painless, and the TBB thing made it doable for us, because if we would have actually needed to set out and program all the really hard threading and locking stuff, we would pretty sure have failed somewhere down the track. We played around with WordPress and a couple of other projects, but just to stick with the WordPress hack that we did, we replaced one for loop that initializes all the modules with a parallel for, because the initialization of the modules is for the most part side effect free, so we thought we can probably just speed it up by loading them all in parallel. And on an 8-core CPU we got a 7 times speed up in the page rendering, so we really dramatically speeded it up. And the interesting bit is, if you compare it to a normal Apache-based setup where you run mod.php, and you dramatically drop your resource usage, because you only need a very slim front-end layer like Nginx or any of the other really slim web servers, and behind that you're actually running machine code, because you have C++ that is compiled down to a real binary. So you're not interpreting anything on the fly anymore. You're not interpreting a PHP source. You're really running a real Unix binary, and that that speeds up the page load times immensely and drops the resource usage as well. That was the first project. But PHP isn't the only language that's used on the web. Perl is another one that is still very, very widely used, even though Ruby is sort of taking over more and more of that space. But Perl is still used in a lot of really large legacy code bases and also in a number of really big sites. So we tried to make threaded Perl. And threading interpreters isn't something that is incredibly straightforward. There are a lot of problems when you try to thread an interpreter. And the PHP guys already said, like, PHP doesn't work. We tried it with Perl because there is already threaded Perl. We thought maybe that would work. And we came up with something called Threads TBB, which is a new threading approach to Perl, because the one threading approach that we have in Perl at the moment is sort of supported-ish, but is not really used widely. There is an older version that was stripped out a couple of releases ago and replaced with the current version, which failed horribly. And we thought we can probably base it on TBB as well, because it already worked for hip-hop. We can probably try it in here as well. Turned out that it isn't straightforward, because the startup cost of a new interpreter is really, really expensive. And we tried to get around that with something called deep cloning. So we tried to actually avoid deep cloning by only copying the data, a very shallow copy of the data structures upon initialization of a new interpreter, to reduce the startup cost and only copy the full data structure if we actually need it, because a lot of times you carry along a lot of data structures that you actually don't need in that very step, and you're processing in the moment. But for a complete interpreter startup, you actually have to carry them over. So we tried to get around that, and we got a massive speed up in interpreter startup, and therefore a bigger gain in threading projects. We still have a startup cost, but the startup cost is only once, and after that the interpreters keep running, so we can just add things to them and tasks to them, and we have that startup cost only once. And this is a model that can definitely work for other interpreters as well. So if anyone in here is actually implementing interpreters or trying to thread an interpreted language, look at Threads TBB and the underlying C code that is in there on how we actually went about doing all that stuff. We have a couple of demos up on geopic.me. There is a Perl demo on geopic.me/Perl, which is really nicely. The hip-hop demo, I tried it right now just before, and it seems to not pick up any images from Twitter. It is a Twitter feed that is parsed for images, but I don't know. Either there are no geocoded Twitter images around here, or it just doesn't pick it up. What it does is it picks your current location with the HTML5 tag and passes that on to our API, either the Perl one or the hip-hop one, and tries to find images, and then does scaling on the images, and just as a really little gimmicky project. The background for the project was that I always hate to look at some scientific paper. I want to actually have code in front of me and play with code, and that is sort of the only thing that is true to me, because anyone can write anything up, and yeah, I don't trust anyone. I only trust code that's provable. So that's why we have geopic.me. It's all the code base is entirely in GitHub, so you can actually look at it. You can browse it in a nice browser, and it's all free, obviously. Future parallel. We heard it before. We have to accept that parallel is normal in the meantime. So if you have more than one CPU, you're running stuff in parallel. We already did that for many, many years, but we tried to sort of hide that parallelism in the operating system, and came up with multitasking and all that stuff. And it is a normal operation mode that we are using for years already. We just try to not use it in our own code. Consumer-grade CPUs are multi-core CPUs in the meantime, and we have to know how to program them, and we have to know how to use them. The simple way is to just fire up 5 daemons of the same thing and try to make them sort out their problems and program around the problems in the application code. But that's definitely not how it will work in the future, because if you have 20 or 50 cores in your laptop, you probably have to, or in your server, your sysadmins will probably force you to actually use them, because they are not paying for them to just idle around. So parallel execution as default model, threading and message passing is 2 models to actually address that problem. There are more, but threading and and message passing is probably the most prominent ones. And just get into the mindset that even as a web developer, you probably have to deal with multiple CPUs, with a stack that supports, or a language that supports more than one execution path. Think about problems that you could actually solve in parallel. So, get up to date with everything multi-core.
Yeah,
that's for you again.
That's for me. Let me see if it works. So essentially, yeah, this is what we have done in the previous years. So we started as a different company. This was at the time when we had venture capital backing, and the main demand for massive use of the original multi-core chips was from telcos. So we worked with the Netra division. We brought the first Niagara servers to New Zealand. It was an interesting story until 2008 came and happened what you probably know about Sun Microsystems, and we followed. But in the process, the Otago University became the first OpenSpark Center of Excellence in the world outside the United States, thanks to our community, and the testbed is still there. I'm not sure if they are using it. So that brought us to this big project that Len summarized here. And in order for us to keep growing and keep creating the awareness about parallel programming, we started to do the mini-comps. We started in Wellington, then in Brisbane, and now we feel strong enough that we can organize our own conference on multi-core. In the meantime, we are members of the New Zealand Square Kilometre Array Industry Consortium, which means anything else that we are the guys that raise the hand and say, look, whatever you want to do, someone needs to write the code for it. And there is a business component and say, we want to be those guys, but on the other hand, they say, don't dream so wildly, because whatever are you thinking, it's just not that simple to do. IBM is trying to write a new language called Extend that we have been experimenting a little bit. And the purpose of this slide is just to give you a basic snapshot about a number of interests, because again, there is numbers of science here, but this is an absolutely day-to-day project. So now I just want to finish doing a little bit of new marketing about what are we aiming to do. And it's a sort of get-together in Wellington, the same place where LCA was in 2010. And what are we aiming to do, again, as a business and as evangelization, as keep building the ecosystem? It's that the guys that were sitting on that boardroom as statues, remember that slide, they start to realize that, look, if you want performance, if you want to cope with applications, you need to go parallel. And then you don't need to ask just to your vendor. We can discuss this together. And a lot of people agreed on that to be speakers. And these are the people who are coming from Australia and United States, just because they think that the concept is good. New Zealand is a nice place to visit too, so that's an excuse. But essentially, I mean, this guy, it's on the OpenCL group. This is the director of the software division. This guy works in Boston. It's a Kiwi too. So it's an interesting lineup, but at the same time, what we are aiming to keep creating and pushing is an entire ecosystem, which means we convince investors to come here. I mean, to the conference, because at the end of the day, like every breakthrough, like everything new, someone needs to pay for it. Someone needs to take the risk. So we are also inviting other developers to join. So it's more than a talk fest. It's a gathering of interest. And that was the purpose of our presentation, telling you a specific project on our ecosystem and how we have been working and how we will continue working. And I unashamedly will invite you again to our conference in a couple of months in beautiful Wellington, New Zealand. And here are leaflets and business cards. So I just want to thank you for your time, and we are open for questions. Thank you very much.
Some questions?
Hi. What about mobile? I work
Yes.
in mobile myself, and I think the average mobile developer is probably still saying, that stuff doesn't apply to me.
It is. So, now, essentially, it's independent of its mobile desktop server. I mean, we can say it's in the cloud, and you can have your simple app, but the servers are in the cloud, and those clouds need to deal with massively things, and then you want to do those.
Sorry. Mobile is pretty simple. We are in mobile in the moment at a stage where the single CPU devices are still dominant, but there are multiple multi-CPU devices already coming up. For mobile, it depends very heavily if you use a framework that supports the underlying CPU architecture entirely with this multi-threading or not. There is a couple of sort of web frameworks that you can use on multiple platforms that probably just rely on a rendering engine that does the whole threading for you. If you're doing that, you're probably fine. If you're going native on iOS or Android and so on, I don't know Android too well, but I know on iOS there is actually a threading library already that can be used, but I don't know when the first devices come out that actually have really a lot of CPUs or a lot of cores that it really starts to pay off to use multi-threading. But it is definitely in the coming. It is probably just a year or two ahead, instead of like being there right now for our consumer-grade CPUs already.
I think that the ARM has already multi-core chips on the mobile. Yeah. So I can't remember if they are already in the market. Yes.
Hey, thanks for the talk. Just with respect to the hip-hop stuff you've done, and you talked about unrolling loops and things like that, is this just for one server which happens to have a quad-core processor or something, or are you talking about a larger setup?
No, it scales.
Okay, because for instance, a lot of our websites we might have a quad-core processor, but we have so many virtual machines running on them that, for all intensive purposes, they're not going to get access to a whole bunch of separate threads to work on anyway. So is this like one really data-intensive website you're talking about, or something like, for instance, Facebook, which just has lots and lots and lots of small tasks which needs to be done with so many users?
Here. Okay.
That's pretty simple. Whenever you do some side effect free for each loop, or any sort of loop construct that is side effect free, where you're not relying on the response of the first one or the return code of the first one, you can actually run it in parallel. If you have, I doubt there is a server out there without a quad-core, at least quad-core CPU. I heavily doubt that. So TBB would start to optimize. It tries to find out how many CPUs you have in your system. It would start to distribute threads onto as many CPUs as it can get a hold of, or you can actually manually tune it. But by default, it would auto-scale to the amount of CPUs you have, and it would start using those CPUs right away for everything where you use our parallel for or parallel reduce instead of a normal for each loop. And the code change is actually pretty small. We've even written a little PHP plugin that you can plug into a normal send PHP to have the same functionality available, just without the optimization, so that you're not locked in one way and can't go back with your code base anymore. So you're actually you're not losing anything. You're just calling a normal for each loop or so. So the gains are there from the moment you start to using a parallel 4. The more you optimize your code base, obviously, the better you use the CPUs underneath. For example, if you do a scaling over 100 images, if you do that on 8 cores in parallel, or if you do that serially, is a really big difference. But if you do simple, small tasks, the speed up might not be as much, obviously, as with scaling an image, but it is still noticeable. It is still a speed up.
Does using TBB tie you to Intel hardware? Can it run on like multi-core ARMs and stuff?
It's not tied into anything. The TBB library has something called backends, I think. I'm not quite sure. Don't nail me on that one. But there is different hardware architectures that they've actually implemented it against. And it is an open library, so everyone can implement whatever he wants to. I'm not sure if the ARM one is there already or not, but there is definitely pretty much all other standard CPU architectures there in the moment, so you can deploy onto whatever underlying architecture you want to deploy. The Intel approach is not to lock you into Intel products. The Intel approach is to produce a really good library that can work cross-platform, and also with having in mind that if you're using another platform, that you can always move to Intel, obviously. But the idea was to not really lock you into something that is Intel only, also licensing-wise, also hardware-wise.
Do you think, I think the libraries are really good. I was just wondering if you think in the future, if everyone needs to be doing multi-core and threading, maybe we shouldn't be relying on libraries, we'll just need to learn to program. Like we learn to program in object-oriented ways, or do we need to learn to program as students, so when we're young kids, learn to program in this way and get our mind around it?
Tricky one. I would try to learn the basics of at least how threading works and how message passing works. Just the basic concepts behind it. I wouldn't probably set out to write a huge project on a bare bones threading approach. For that, I would use Silk or TBB or CUDA or any of the actual projects that are there for writing into massively parallel architectures, and or use something called Erlang, which is a really, really good language that I love a lot, and that I'll talk about in my next talk, actually, which is a message passing environment that gives you a lot of that stuff for free already. I would, if you're starting out to program, I would learn at least a threading approach and a message passing approach.
Any more questions?
So because we have a couple of minutes, I, believe me, just want to insist to invite all of them, or at least pass the word about our Multicore World Conference. We know that we will lose money, but the important thing is that our crusade on making more people aware of the need of parallel programming is something that requires the support of all the community and all the communities. So even if you don't remotely plan to attend, I would appreciate if all of you at least pass the parcel, let other people know. You never know who can be out there interested, and we strongly believe that the potential of talent available in the region, in Australia and New Zealand, can make us a global hub on this experience. And that's something that we constantly promote, and the people come through the world because these isolated pockets exist here. So thank you very much.
Thank you very much. Thanks, Nicholas and Lenz, for a very interesting talk, and I've got a small gift for you, Nicholas, from the organisers. It's a little penguin.
Okay, thank you
locally
very much.
made. And you'll get yours in the next session. Okay, our next session starts at 11:30. So